Greetings to everyone. Welcome to today's lesson in Indices 4. And all the lessons that I've done should be revised so that one will be on a very good page for today's lesson. So right away, Indices 4, we'll be going through that, and the concepts that we have already treated will be needed in order to solve the questions that we are actually going to consider. I am William Obeng-Denteh, Department of Mathematics, Kwame University of Science and Technology, Kumasi, Ghana. You are most welcome. So straight away, I want to look at this question. Simplify square root of x times square root of s cubed over x raised to the power negative 3. Want to look at that. So square root of x times square root of s cubed over x raised to the power negative 3. Now, for us to do this, we'll go through the step-by-step process and it will be understood. Now, in the previous lessons, we saw that square root of x can be written as x raised to the power half. And square root of s cubed can also be written as x raised to the power 3 on 2. The 3 here goes up over 2, where the half times the 3 is giving us the square root. So for square roots, the half is always a constant. And then if there is a power, we multiply the numerator by that power if it's a whole number. And so we've been able to express the sets form over here into the indicial forms, and then we got a denominator. Now over here, we want to clear the denominator, so we shall multiply the numerator and the denominator by x cubed, x cubed. So it's as if x cubed is dividing x cubed, so that we still go back to our 1. Now when we do that, the negative 3 and positive 3 will clear each other, and we shall get 0. Now, from there, we shall then need to actually simplify the numerators because we have the bases being the same. Then we will add their indices. So we will actually do that and see the value that we shall get. So straight away, we do the rough work aside. So we have half plus 3 on 2 plus 3 on 1. And our LCM will be 2. So 2 divides 2, 1. 1 times 1 gives us 1. This 2 divides 2 and then 3. So 1 times that gives us 3. And then 1 divides 2, so we get 2. 2 times 3 will give us 6. So we should actually get 10 on 2, and that will give us 5. 10 on 2 give us 5. Very important. Okay, so right away, we've seen that when we add them, then we shall get, so half plus this half plus 3 on 2 plus this 3 on 1. The LCM will be 2. So 2 divides 2, 1. 1 times 1 gives us 1. 2 divides 2, 1. 1 times 3 gives us 3. And then 1 divides 2, 2. So 2 times 3 is 6. When we add all of them, then we shall actually get 10. And when we get a 10 over our 2, and then when we simplify, we get 5. So this will give us that. Okay, so we get 5. So what we are going to do is that we now write our x raised to the power 5. That's the result of the addition or the sum of the indices. Over here, negative 3 plus positive 3 will give us 0. So we get x raised to the power 0, which you know from the previous lessons that is 1. So you get x raised to the power 5. And so that's how the whole thing. So there's the rough work. You do it aside, and when you finish, if you use a pencil, you can erase it or you can cross it over. So this is actually the value that we'll get when we solve this. So look through it again and get the processes. You convert the sets into the indicial forms. And when the bases are the same, you add the indices. Now, after adding the indices, you simplify it. And after simplification, you come to the end of the section. And so that's how the whole thing should be. So basically, we end on this by saying that our final answer will be x raised to the power 5. So we want to look at the next question, and that is the question 2. And what that is saying is that we should solve for real x, the equation given on the slides. Now, once we get that equation, basically what we are going to do is that we will simplify what we have in the brackets. And after simplifying that, we will then try and do the substitutions. After doing the substitutions, then we shall actually get the value for that one. And so we have this whole expression, and we have to solve for real x. And so we need to go through the process. And so let's get started right away. And so we have our expression over here. Now, this one was from a certain expression in indices that give us this. So we need to go back to that. So when we write 3 raised to the power 2x times 3, and want to simplify, that will take us back here because this 3 is raised to the power 1. So the bases are the same, so it gets back here. So we need to rewrite it in this way from the original expression that gave us this. And then we'll maintain the rest. So from here, we'll then multiply our 4 by the 3. And then we'll keep on simplifying. So 3 times 4 will give us 12. And then we have 3 raised to the power 2x, but we can rewrite it as 3 raised to the power x all squared. And this is also from the previous lessons that we introduced. So we know that anytime we have this, we can bring this out, even they are multiplying themselves, so that we get it in the quadratic form in 3 raised to the power x. So here, we'll then do some substitutions. We shall represent this by y, and then from there, we move on. So we said that let 3 raised to the power x be equal to y. So over here, we put y there, we get y squared, we put y there, and then we'll now factorize the quadratic expression. So we get 12y squared, 17y minus 7. Now we need to factorize this. And for us to do that, we pick the coefficient of y squared and multiply it by the constant -7 and put the value down. And so when we multiply 12 and -7, we shall get -84. Now we need to split this into 2. So that we'll get 4 terms, and then each pair we shall do the factorization there. And so we got 12 times -7, which gave us -84. We want 2 factors that will multiply to give us -84, but when we add them, we shall get 17. And so we need that value, and that will be 21y and then -4y. 21y and then -4y. And when we do that, it means that we are on course. So we have our 21y minus 4y. So that when we compute this, it takes us back to the 17y. But we've been able to do that and split them, the 17y, into 2. Now we can concentrate on this and do the factorization, concentrate on that and do the factorization and get the pairs. Right. So from there, we now do our factorization. We have 3y being common here, 3y being common there. So when we divide this by 3y, 3 into the 12 will give us 4. And then y into this y squared gives us y. So this times that will give us back our 12y squared. And then 3 into 21 will be 7. And then y into y will be 1. So 3y times 7 takes us back to the 21y. Over here, 4 and 7, it's only 1 that can be the factor. So we bring the -1 out, and this will be positive 4y plus 7. Now, this linear factor is common to both. And so we shall do well to factorize this out. And when we do that, we'll be left with 3y minus 1, and that will also find itself in the bracket. And so that is how we actually carry that out. So we have our common factor times 3y minus 1 here. It means that 3y minus 1 is equal to 0, or 4y plus 7 is equal to 0. And when we do that, it means that our y from here, because this is equal to 0, we get y to be equal to 1 over 3. And then here, when we make y the subject, we get y being equal to negative 7 over 4. Now, when we started, we said that let 3 raised to the power x be equal to y. So we go back to that expression, and in place of y, we put 3 raised to the power x over there. And so when we do that, that will help us to simplify everything. So we get our 3 raised to the power x being equal to 1 over 3. Now, in our previous lessons, we learned that 1 over 3 can be written as 3 raised to the power negative 1. And because this base and that base are the same, we could see that 3 raised to the power x, what can be placed here to give us that? So it means that our x will be negative 1. So x is equal to negative 1 when we want to do for the x. And that ends this lesson. Thank you for your attention. Continue to practice. Have a great day. Bye for now.